Hi guys, today we're going to be looking at some binomials and the binomial theorem, which will help us kind of expand and take away some of the math that we have to do so we can kind of simplify things. So the first thing we really want to look at today is Pascal's triangle. Now this is a triangle that you can use on anything from here on out. You don't have to memorize this, although it's a pretty simple thing to look at. We're going to kind of look through what it is. So it's a pattern of numbers that was discovered in the 13th century. So all we're doing is adding the two numbers directly above to get to the next row. So all of the outside numbers on the triangle are 1. So if we continue this, I see that I've got my outside value is 1, and my outside value is always going to be 1. It doesn't matter what happens the rest of the way. Well, then to get to this middle box, I see I've got 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1, again, is my 4. So now I can do my row number 5 here. So 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, and then I've got another 5 here. So you'll see, and this is actually very important, that we actually start at row 0. And this is because we're looking at some exponential stuff, so we can start with an exponent of 0, which would give us a value of 1. Just remember when we're using this that we start at row 0. Okay, so what we're going to be really looking at is, first we want to expand this binomial. So when I expand a binomial, that tells me that I have to multiply a plus b times a plus b times a plus b. So let's go ahead and do that. So there's 3 of them is what that exponent tells me. Okay, so when we're doing this, we can pick any 2. I generally start at the beginning. So I know that I've got a times a, which gives me a squared, and then I've got ba or ab. I'm going to actually keep them in alphabetical order, so this will be AB. And then I've got B squared. So then I've got that times, again, my A plus B. So let's simplify this a little bit. So now I see I've got A squared plus 2AB plus B squared times A plus B. Okay, so now let's go ahead and multiply that one. And when I multiply this in, right, that's all I'm doing is double distribution, or I'm doing my multiplication. I end up with A cubed plus 2a squared b plus 4, nope, that's a plus, let me get my eraser. Oh, come on, eraser. Plus a b squared, and now I'm going to multiply my b in, plus a squared b plus 2ab squared plus b cubed. So what I end up with once I actually fully simplify this, I end up with my a cubed plus 3a squared b plus 3ab squared plus b cubed. So I want you to notice the coefficients. And remember, the coefficients are the numbers in front. Why is this not doing this? So I've got a 1, 3, 3, 1. That should hopefully look familiar as something up here. 1, 3, 3, 1. So these are the coefficients from row number 3. If I look back up at Pascal's triangle, I see that those are the coefficients there. So now we're going to actually use that to help us kind of get there. So here's the binomial theorem, and this is something we're just going to walk through several examples together. So if n is a natural number, so then I've got a plus b to the n, then here's what I'm looking at. So I take the combination, right, and we've looked at combinations in the past, of n things, that's my total things, which was my exponent taken 0 at a time, times my a to the n, b to the o, plus, and then I start increasing my number every time. So you'll see I increase this value every time until I get to the end. And we're going to look at this at the very end and kind of give us some simple steps. So you'll notice my exponent with my a decreases 1 every single time, all the way down till 0. My exponent of my b starts at 0, and it goes up 1 every single time. So this is just kind of fancy notation. It tells me it is the sum, right? That's what this value is the sum starting at k equals 0, so starting at my 0 value all the way to n of the combination times my my things that are in my terms that are inside my parentheses. Okay, so now we're going to use the binomial theorem to kind of expand this. Instead of having to write it out, a plus b times a plus b times a plus b times a, that just gets to be too many things. So now we're going to use the binomial theorem to expand that and to really kind of look at it. Okay, so I see I've got 5 things, my 5 exponent. So I've got 5c0 times a to the 5th b to the 0. Okay, so you'll notice that I start here and I start at 0. So then I add to that 1 a to the 4th, because that value decreases, b to the 1st, and that value increases, plus 5c2 a to the 3rd b squared, plus combination 3 a squared b to the 3rd, plus combination taking 4 things at a time, a to the 1st b to the 4th, plus my combination of all 5 things, a to the 0 b to the 5th. And I know that I'm done and I've written out each piece of my using the binomial theorem, because I've reached, my exponents are back to being 0 and 5 and they've switched places. So that's how I can really understand and know that. So then if I look at this, I'm going to kind of cheat a little bit. I'm going to use Pascal's triangle. You could, in your calculator, find all of these combination values, okay? Or we can use Pascal's triangle and look at row 5, which is back up here, which tells me I've got 1, 5, 10, 10, 5, 1. So I'm going to go ahead and use that. So I know I'm going to have 1, 5, 10, 10, 5, 1. And I have plus in front of all of them because I'm adding them. This is the summation. So now I can just look at my variables. Okay, so there's really one thing I can simplify there, because I know b to the 0 is just 1, so it can go away. So I've got a to the 5th. These can't really simplify, so I've got a to the 4th, b to the 1st. I can get rid of that 1 if I really want to. A cubed b squared, a squared b cubed, and then I've got a b to the 4th, and then I've just got b to the 5th. Okay, so then I can look, and if I need to simplify anything else, I can, but there's nothing else that I can simplify. So I've gone ahead and I used Pascal's triangle to find me the coefficients of how I'm going to be working with those variables. Okay, so here are a couple more. I want to go ahead and walk through this one as well. So again, I would have x plus y times x plus y times x plus y times x plus y 7 times, and I could multiply those all out. That would take quite a while. So I really don't want to do that. So using Pascal's triangle, I would be looking at row 7, which we don't have up above, but we could kind of expand our Pascal's triangle a little bit. And if you want one printed out, just let me know and I'll print you out one. But when I expand it, I end up with my coefficients being 1, 7, 21, 35, 35, 21, 7, and 1. Ooh, and those are very close together, so I'm going to separate them a little bit. So then I know that this works really well when I just have variables in here. We'll look at an example when there's numbers thrown in as well. So I know that my x value starts with the highest exponent, and it would be y to the 0, which just goes away. So then I've got x to the 6th, y. Then I've got x to the 5th, y squared. And then I've got x to the 4th, y cubed. And then I've got x cubed, y to the 4th. And then I've got x squared, y to the 5th. And x, y to the 6th. And then y to the 7th. So all I've done is I've used Pascal's triangle to help me expand this without actually having to multiply every single chunk. Okay, so now let's look at what the heck happens if I have coefficients other than 1. So in those previous examples, I just had like x and y, and now I've got other values and other numbers to deal with. We're going to do this the same way we did before, but we just have a little something that we have to add in. Okay, so I'm going to color code these just to make it easier for me to handle and for me to see. So I would have my combinations, right? And I'm going to write my combinations in green. 6, 5. So those are all in green. Okay, so I'm still going to be finding all of those combinations. So then I'm going to look at my x's in purple. So I see that my x is going to start with the 6th, and then to the 5th, and then to the 4th, 3rd, squared, x, and then I don't have an x for my final one. So now I'm going to use red to deal with this -3. And we really can't forget that it's a -3 instead of a +3, because it actually really does matter. Okay, so here I would see I have -3 to the 0. I have negative 3 to the first power, negative 3 squared, negative 3 cubed. And you'll see that my exponent is increasing each time. All the way till the very end. So now I can go ahead and simplify and find all of these values. Okay, so using your calculator or Desmos or Pascal's triangle, we could be able to find all of the green chunks. So let's take a second and just go ahead and do that. So I'm going to have Desmos actually help me do all of these. So if I pull up my Desmos, I've got it up here, and you can't see it on your screen, but you know how to set it up. So I'd find my combination taking 0 at a time. There's 1. So then combinations 1 at a time, there's 6. So I'm going to go back and we're going to kind of work these together. So I know that this was 1, this value was 6. So then let's go see with 2 and 3. So if I put in here 2, I have 15 and 3 would be 20. So back to here, I've got 15 and 20. So then I know one cool thing about doing these combinations and using Pascal's triangle is that it is symmetrical around the middle. So I don't really have to go any further because I also know that this would be 15 and this would be 6 and this would be 1. So now I've got those figured out. So now let's go ahead and simplify this negative 3 that I have to deal with and also add in. So I know anything to the 0 is 1. I know negative 3 to the first power would be negative 3. I know negative 3 squared, that negative goes away and it becomes a positive 9. Negative 3 cubed is that negative 27. And now I'm getting to the point where I'm going to need my calculator, or I'm just going to go ahead and use Desmos since I have it open. So 3 to the 4th is 81. And again, I know that that's going to be a positive 81. Negative 3 to the 5th, again, something I don't know, is 243. It's going to be negative because it's a negative 243, and then this 3 to the 6th, let's go back in here, will be 729. So now I have enough information to actually kind of finally sit down and simplify it. So let's look at these in chunks, right? So here is my first chunk, and I see I've got 1 times my x to the 6th. Well, 1 times 1 is 1, and x to the 6th. Okay, so now let's look at this second chunk right here. I've got 6 times a negative 3, which gives me a negative 18 x to the 5th. Let's see here, we'll do this one. So I've got 15 times 9, which again, I'm going to use my calculator because I don't know what that is. 15 times 9 is 135. So, and it's going to be a positive 135x to the 4th. And I'm just going to alternate colors just so that I can keep track. Here I see I've got a negative value, and 20 times 27. Woo, that's a really big number. Something else is going on here that you can't see. There we go. 540. So this would be minus 540x cubed. I'm going to go back to purple, right? I'm just alternating colors so that we can kind of see things. 15 times 81, I would have to again do 15 times 81 is 1215. And again, it's a positive. And my x squared still stays there. So then here again, I multiply 6 times that negative 243. 6 times 243 is 1458 minus 1458x. And then I just have my final one here, which is just that 729. Okay, so now I have the fully expanded version using Pascal's triangle, or doing like we did here with our combinations and looking at each chunk individually and then adding them together. So you'll see you have several examples here, and I'm going to go ahead and fill them out and post the answers for you to kind of work through and try. So real quick, we'll kind of look at this in our next little video so we can kind of start fresh and have a simplified way to kind of look at all of this.